Nice. Equivalent fractions. So, by the time we're done today, you guys should be able to figure out what an equivalent fraction, what does equivalent even mean?
Equal.
Equal means the same, okay? We're going to reduce fractions into our simplest form. Now, I love pie. Like real pie, like you eat pie. So, Thanksgiving, I got myself a pie. That was my slice. That's a big slice, but I only ate one.
Okay.
I only ate one. I cut my pie into 2 pieces. I only ate 1 piece. So it's not that big a deal, right? My, my wife's like, no, you can't eat half a pie. I said, fine. I'll cut it in 4 pieces and I'll eat 2 of them. And just have 2 pieces. It's the same, right? Or, fine, cut it into 8. I'll still have 4 of them. It's still the same amount, right? That's the idea. Honestly, my wife is the king of this. She'll make a pan of brownies, okay? And she'll cut a row, but then she'll cut the row into like 10 pieces. I said, well, what's the difference? I eat 1 big one, you eat 10 little ones. We still eat the same amount, right? Half, same as 2/4 is the same as 4/8. Like, it is the same. It is equivalent. Those are equivalent fractions. Okay? We need to find, you're going to be asked to find equivalent fractions for, okay, so we need to find 2 equivalent fractions for 10, 12. Meaning, equivalent means equal. There are a couple of ways to do it. We got 10 over 12. We can scale it down, meaning divide top and bottom by the same thing, or we can scale it up by multiplying top and bottom by the same thing. The key thing there is by the same thing. So if I wanted to scale it down, what's a common factor that 10 and 12 have? 2. So we can divide this by 2, divide by 2, and I end up with 10 divided by 2, which is 5, 12 divided by 2, which is 6. The most important part of this is make sure that you are dividing by the same number. Whatever you do to the top, you have to do to the bottom. Now, we could go 10 12ths, and we could scale it up by multiplying. And we can multiply by 2, we can multiply by 5, we can multiply by 10, 100, whatever, as long as it's the same number. As long as it's the same number. 20 over 24. Back to the pie thing. If I take that pie and I cut it into 12 pieces and I eat 10 of them, would be the same as if I cut that pie into 6 pieces and ate 5 of them. It would be the same amount of pie, plus a bellyache. Okay? Same thing here. Cut it into 24 small pieces, but I still eat 20 of them. It's the same. Yeah. Next. Four sixths, same thing. You got your pan of brownies if you want. I know I'm probably making you guys hungry. Cut it into 6 squares. Eat 4 of them would be the same as if you cut it into 12 squares and ate 8 of them. It's the same. Is it 12? Yeah, it is 12. It'd be the same as if you cut it into 3 big squares and ate 2 of them. That's how I always like to. I only ate 2. Like this. What? All right. You're also going to be asked to do this. Find the number. Find the missing number. How did you come up with 12? What did you do? Okay. Whatever you do the top, you have to do the bottom. So in order to go from 5 to 20, all right, you multiply it by 4. So you got to multiply the top by 4. You end up with 12 here. Simple enough. Next one. It goes in the box. Jaden. 100. How did you come up with that? Times 20. Top and bottom, both by 20. Has to be the same thing. 4 times 20 is 80, and then 5 times 20 is 100. Exactly. Good. Nine. 9 times 3 is 27. 3 times 3, because same thing, is 9. Good. Now comes the part that I want you all to understand. There's some of it, actually, this is the, quote, new math. Okay? This is going to be, some of it is going to be new. If you take this home, a lot of times some of your parents are going to be like, well, this is how you do it. I'm going to show you another way that your parents probably didn't use. Okay? And then they're going to say, oh, this is the new method. In the past, what we've done to reduce is we've divided. And we want to divide by the greatest common factor. So, like, when you have this, it says write each fraction in simplest form, we would divide. And a lot of you will look at this and go, well, let's divide by 2 because it's even, which is cool. So you divide it by 2, divide by 2, and you end up with 10 over 24. Some of you would stop there. But that is not simplest form. The idea of simplest form is that the numerator and the denominator, their greatest common factor is 1. Okay? What is a common factor that 10 and 24 have? 2. They still have the common factor of 2. Like if you listed the factors of 10, it would be 1, 2, 5, 10. You listed the factors of 24, it would be 1, 2, 3, 4, 6, 8, 12, 24. They still have a greatest, actually their greatest common factor still is 2. So we would still divide by 2, and you end up with 5 over 12. Then you know, right now you know you're at greatest or you're at simplest form simply because what are the factors of 5? 1 and 5. Does 12 have a factor of 5? No, it doesn't. So you know that their greatest common factor is 1. You know this is simplest form. Now that is the old way. I have a cool way. What? Okay, and that's the next thing. That was the other thing. That's probably how many of your parents would want you to do it. 20 divided by 48, and they would go, okay, well, what's the greatest common factor for 20 and 48? And actually, it is not 2. It is 4. The greatest common factor for 20 and 48 is 4. So if you divided by 4 here, you divided by 4 here, you would end up with 5 over 12. Still, we're still using greatest common factor to figure out simplest form. Well, why don't we use multiplication? Tell me what is the prime factorization of 20? 4 and 5, right? 2 and 2. True? And then we've got 48, 6, 8, 2, 3, 2, and 4. And then 2 and 2. So we got, this is our prime factorization of 48. This is our prime factorization of that. That's, once you guys can probably get pretty good at this and probably not even have to make a factor tree to do this. But watch this. Let's make our chart with this. 2, 2, 5, and what is it? 2, 2. How many 2s? 3 of them? 4 of them? 3? True? Okay, watch this. Cross the full ones off. What are we left with? 5. What's 2 times 2? What's 3 times 3? Okay? I just used multiplication to find simplest form. Yeah. Yes, but on a reduced scale, a much reduced scale. Because otherwise you're trying to deal with 20 divided by 4, and when we get into some bigger numbers, that makes it more difficult. I mean, right now, yes, 20 divided by 4, that's pretty simple for you. 48 divided by 4, pretty simple for you guys. But let's say we had 136 over 312. This bottom way that I just showed you is actually, your chances of making a mistake are a little bit less. So if you want to do it the way that your parents learned, and I, quite honestly, I learned when I was a kid, you want to do it that way, fine, do it. But I will tell you this bottom way I just showed you is going to reduce the chances of you making a mistake by quite a bit, because you're dealing with much smaller numbers and you're multiplying smaller numbers. Okay. So I'm going to show it to you guys one more time quickly, just to, that's the same. Well, let's just, first of all, simplest form. It already is. It's kind of a trick question. Some of you are going to go, well, it's already in simplest form because, well, that's number 7's prime. But what if I did that? What if I said that I had 13 over 39? I mean, we know 13's prime, right? That's not in simplest form, because 13 actually goes into 39 3 times. So divide by 13, divide by 13, and you'd end up with 1/3. And there's your simplest form. So just because you have a prime number in it doesn't mean it's necessarily in simplest form. So be careful about that little trick. All right. So again, to show you that the new way that I kind of think is cool, let's just say we had the fraction 64 over 72. A lot of you would want to divide by 2 or divide by 4 or whatever. Why don't we just do our thing? 64 is what? 8 and 8. And then we got 2 and 4, 2 and 2, 2 and 4, 2 and 2, 72. I'll do 72 over here. 8, 9, 3, 3, 4, 2, 2, 2. So we make our chart. We got how many 2s? 1, 2, 3, 4, 5, 6. 2, 2, 2, 2, 2, 2. And then we got 1, 2, 3, 2, 2, 2, and then a pair of 3s. That's it. Cross those off. We're left with this. 2 times 2 is what? Times 2 is 8. So it equals 8 over 9. Do it the old way?
Just be 8 over 9.
Do it. Well, we'll just do it. We'll just do it. That's fine. That's fine. So, honestly, probably most of you will just see that it's even, so you'll divide by 2, and then you're going to go, well, what's 64 divided by 2? And you'll end up with 32 over, what is it, 36? And then it's still even, so you'll divide by 2, and you end up with 16 over 18. And then you go, well, it's still even. But I'd be willing to bet that some of the people in this room are going to stop at one of these because I already did my division. You're like, oh, I already did my division. So you'll stop there. Divide by 2, and you end up with, 8 over 9. And then you'll probably stop. You could have divided by 8 in the beginning, but how many of you recognize that you could divide by 8 right away? In this room, we got a few of you, which I believe a few of you would have recognized that you can divide by 8, but I'd be willing to bet that most of you would divide by 2. So, I don't know. I think that using prime factorization is a really valuable tool, and it reduces your chances of making a mistake tremendously. So your homework is written right up there on the board. Page 188, 8 to 48, or 12 to 48 even. You're going to be asked to do the exact same things we just asked you to do. If you're